Welcome to today's Explainer. If you've ever worked with rigid, unforgiving materials like acrylic, you already know that sinking feeling in your stomach when you make a bad cut or a slightly off bend. Boom, suddenly your expensive sheet of plastic is totally ruined. Well, today, we're looking at a foolproof method to avoid exactly that. We're going to break down how to produce a perfect cardboard model and then flawlessly transfer that shape onto two distinct pieces of acrylic. It's a journey from a flat, two-dimensional sketch all the way to a precise, technology-ready, illuminated 3D object.
So here's our game plan for today. We'll start with prototyping with paper, move into shaping the cardboard model, and then transferring to acrylic. After that, we hit forming the 3D structure, and finally, next steps, adding electronics. All right, let's jump right in. Phase 1. Prototyping with paper, the ultimate low-stakes start.
These first steps, they are incredibly accessible. We're just going to prepare our paper on a standard cutting mat, establish a firm centerfold line, and then map out our initial 2D geometry. Getting these abstract ideas laid out physically right away gives us a super clear runway to just get our hands dirty and start building.
And it all starts with that very first physical action, creating a crisp, tactile fold right down the center of our base material. It seems small, but this is absolutely vital. It's not just about making the paper smaller, right? This crease acts as our center line, our anchor point. It's literally the foundation for all the symmetric geometry that's going to follow. Moving on to Phase 2, shaping the cardboard model, taking this from 2D to physical.
We start out with a perfectly plotted two-dimensional arc drawn inside a rectangular boundary. That represents our math. Then we apply that math in the real world by grabbing some scissors and cutting directly along that plotted line. Using cardboard here acts as our safe zone, basically. It lets us rapidly iterate, mess up, and cut out our shape with absolutely zero consequences.
Once you've cleared away that inevitable mess of excess paper scraps on your desk, this is your reward, the finalized flat geometry. It's this beautifully curved, almost kite-like shape. It looks simple enough, sure, but this specific flat layout is the secret sauce that will eventually give our final 3D object its unique, sweeping contour.
Now, if we want a robust build, we absolutely cannot ignore material thickness. Those double lines you trace along the curved edge, they visualize exactly that. They act as our guide to trace and cut not just one, but two separate pieces of thick acrylic. Layering these two distinct acrylic cutouts is the key step that gives our final build its real depth and structural integrity.
Which brings us to Phase 3, transferring to acrylic, where precision really matters.
Think about it like this. Cardboard basically begs you to make mistakes. It's flexible, it's cheap, and it's perfect for rapid testing. Acrylic, on the other hand, man, it is rigid, unforgiving, and it demands absolute precision. This stark contrast is exactly why we build that cardboard model first. It literally saves us from ruining incredibly expensive plastic.
So let's take a look at the flat layout diagram for one of our acrylic strips. Do you notice those bold vertical division lines segmenting the rectangle? Each one of those lines dictates the exact spot where we will apply heat to physically bend the acrylic later on.
To fully grasp the geometry here, let's break down the numbers. We've got a central height of 20 units, and that's flanked by two inner drop sections of 10, finishing out with two outer wings measuring 15 each. And because we already worked out this exact scale on our cardboard model first, we can tackle these rigid acrylic measurements with total absolute confidence.
All right, Phase 4, forming the 3D structure. This is where we bring it to life. This is where we get the big payoff. That flat layout diagram with all those critical measurements we just talked about transforms into a perfectly stepped, three-dimensional acrylic form. The outer wings of 15, the drops of 10, and that central height of 20, they all bend precisely into place like a giant puzzle coming together.
So, if you take away only one thing from today, let it be this. Prototyping saved the final material. By actually taking the time to map out the curves and bends on paper first, and really visualizing the thickness required for those two separate pieces of acrylic, we guaranteed that our final bends were totally flawless. Absolutely no wasted acrylic and no wasted time.
Finally, Phase 5, next steps, adding electronics. Let's add the spark.
It's a great question, isn't it? We have our perfectly formed acrylic structure, but how do we actually turn it from a static piece of plastic into a functional illuminated object? Well, because our acrylic housing was bent to such incredibly precise measurements, it is now perfectly dimensioned to hold a custom electronic circuit.
So what actually goes inside? Take a look at how minimal yet highly specific these electronic components are. You can tell they are incredibly tiny.
But these small but mighty parts are about to integrate seamlessly into that custom housing we just built.
To make this actionable for your own build, let's quickly recap the exact components detailed in the source. You're going to need a CR2032 lithium button battery, a corresponding battery holder equipped with roughly 10 cm pre-tinned wires, one standard hole LED featuring long differential leads, which just means one leg is longer than the other so you don't mix up your positive and negative, and finally a 2 cm piece of pre-cut heat shrink tubing to keep all your connections super secure. It's a highly accessible checklist for a really brilliant payoff.
It really is incredible when you step back and look at the whole shebang. The source puts it perfectly. A simple piece of folded paper made this precise, technology-ready acrylic housing possible. That pretty much encapsulates the entire maker's journey we just unpacked in this explainer. We started with a humble center crease on a cheap piece of paper, and we used it to map, test, and flawlessly execute a complex, dual-layered acrylic structure that's ready for custom electronics.
Which leaves us with this final thought for you. The blueprint is officially in your hands. You've seen exactly how a forgiving cardboard model gives way to perfect, rigid acrylic. So, dust off your cutting mat, grab some paper, and tell me, what will you prototype and illuminate next? Thanks for joining me on this explainer today. I honestly can't wait to see what you build.